I'm just going to show you the slide that I probably used in the video. So exponential and logarithmic are, you can kind of draw from them to see some patterns, but they are actually different. Okay, they're very different in the way we're going to approach them. One thing, I don't know if I mentioned it on the video, if you don't have this on your in your notes, is that time is often the y variable when it comes to logarithmic functions, and that throws students off like you wouldn't believe it. Okay, like, so what? You told us time is the x-axis all this time, and all of a sudden it's on the y. Yes, with this one it is. But I'll show you that you don't have to guess. Like, you don't have to guess when it comes to this. The graph never crosses the y-axis. That is due to the asymptote. Okay, it never crosses the y-axis. The exponential never crosses the x-axis, whereas logarithmics, they never cross the y-axis. Okay, so remember that. Another thing to highlight is that logarithmics, you'll have the log and you'll have the natural log. Okay, so ensure that you know that on your calculator you've got both of the buttons. Right? You gotta type in the right one. They will look similar, but they will be different once you start finding points. Okay, so that's something to remember. Did I talk about asymptotes on the video? If I didn't, this is your chance. This is my way out of getting into trouble, right? There's a vertical asymptote, okay, which is x equals to 0. And the general behavior is always quadrant 4 to quadrant 1. Okay, no matter which one, if it's the increasing function or decreasing, it's always quadrant 1 to quadrant 2, or, sorry, 4, or it's quadrant 4 to 1. It doesn't matter how you state it, but it is between those two quadrants that this one stays. And remember, this is not word problems. Okay, once we do word problems, we will most likely not include quadrant 4. 99% of the time. Okay? And keep in mind that this first number, a, gives us a point on the graph. It's not the intercept. It's just when x is equal to 1, y is equal to whatever that a value is. Okay? Always include, I would say, strongly suggested. Okay? Like sometimes it doesn't help us a whole lot, but I would say, and then B determines whether the graph is increasing or decreasing. If B is positive, if you have a plus here, this graph is going to go up like this. If B is negative, right, if it's less than 0, it's going to go down like this from left to right. Keep that in mind. This is in general, right? So your domain and range is 0 to infinity, and range is negative infinity to positive infinity. Notice that for your domain, 0 has a round bracket, because 0 is not included because that's the asymptote, right? So it's almost 0. It's basically saying very, very close to 0, but not including 0. Okay, so there's your domain and range in both notations. I made a mistake on the video. I hope you caught that. There are no y-intercepts, so make sure you have that. Yours says no x-intercept. It's supposed to say no y-intercepts, and I already mentioned that as well. All right, so we're going to jump right into word problems from here. So if you can follow, I don't know how much you've done. Maybe I will take a little bit of time on 34 before I do word problems right away. Okay, so let's go to 34. I'm just asking you to sketch. So we're not going to make a fancy graph here. So I have exponential and logarithmic side by side. Okay. Exponential, right away you're thinking, right? You're thinking all 4 quadrants here, no word problem. This is B, and that is A. And this is exponential. What does this first number tell us when it comes to exponential? Does anybody remember? Y-intercept. So we know that A gives us, is a point on there. And so 0, 2 is going to be on this graph, guaranteed. B tells us increasing or decreasing, right? B is greater than 1, so this is increasing. Okay. So what that means is we have our horizontal asymptote here. This is y equals to 0. Okay? And we're going to go through 0, 2 here and go up from there. That's how you would sketch this. And this page right here is just to kind of get your head to envision this without graphing, so that you know what to expect and to know whether or not you typed it in correctly. Okay? So that's an exponential. Right next door, we've got a logarithmic. Okay? We know that that is A, and we know that whatever's in front of log is our B value. A in this case gives us a point, but it's not the intercept, correct? It's 1A. We know that 1A, whatever that number is going to be on our graph. So it's 1, 2 in this case. B is positive or greater than 0. It's up to you. So what are we expecting? We're expecting an increasing function here as well. And here I'm going to use my space that I have available. In this case, it never crosses the y-axis, so x is equal to 0 is the equation of the asymptote. And it's increasing. So to help me out, I'm going to use this point. 1, 2 is right about there. It does have an x-intercept. I just don't know what it is right now. It'd probably be a good idea to include that, but I know that it's going to come from here, cross that point, and then go this way, increasing from left to right. This is the point 1, 2. Right? Did I do this? I didn't do this one on the video, did I? No. That's why I'm taking my time here. Okay. So for this one, again, an exponential and a logarithmic right next to each other. So here we've got 0, 4. Intercept is a point. B is between 0 and 1. So if it's between 0 and 1, then it's decreasing. And it's exponential. So you've got your x and your y. We will never cross the x-axis. That's y equals to 0, my asymptote. 0, 4 is somewhere there. It's decreasing, so how does this going to go? From left to right? I'm actually going to come from here somewhere, go through that 0, 4, and then keep decreasing as I move to the right. Okay, so there's your, that would be the function that we would expect. Over here, I have 0.15, which is going to be on the graph. B is negative, so it's decreasing. Always, when I talk increasing and decreasing, I always go from left to right. Okay, guys, just like you read a book. Do we still read books? I don't know. I hope so. if there's anything good out of education that I learned, is learned how to read books, okay? I would have never read books if it hadn't been for education. That's just not my natural inclination. Anyways, here we've got our asymptote there, and it's negative. So we know that 1, 5 is somewhere here, and from left to right, we're going to be decreasing. So this is starting here, it goes through it, and it just keeps going. It's just going to keep decreasing from left to right. But 1, 5, I'm just sketching right now. I'm not doing an actual full-on graph. This is just to wrap your head around it. I would expect the x-intercept on an actual graph. I would expect you to find it and go from there, okay? All right, this is just a warm-up here. So let's go to word problems. I did ask you to do a whole bunch of graphing, 35, 36. I keep on saying I'll start with a word problem, right? And then I change my mind. 37 is some matching. I would like you to match. So take the equation on 37 and write it under the corresponding graph, okay? I want you to be able to do that. One thing, this is from a textbook, okay? One thing here is you can rewrite this as y is equal to 0 plus 6 log x. So if there's no number and then plus or minus the log, then you're assuming that it's 0. Same here. This is technically 0 minus 2 natural log of x. Okay? So try to match them. I'll do my attendance and then we'll be back with word problem. Okay, let's see here. I don't know how you approach this, but I looked at all 4 and I realized right away that this has to be a log and this had to be a log, right? Because I can't have x-intercepts with exponentials, right? And these ones cross it, so logs, logs, which means that these two are exponential, exponential. So that's kind of like a bird's eye view. It's like right away you get to figure that out. And then maybe over here, I will focus on left to right. This is decreasing. And this one from left to right is increasing. And what does that tell me? For here, b has to be greater than 1. For this exponential here, b has to be between 0 and 1. Okay, so if I had a lot of options, I might have to dig into that level. Okay, I also know that a, what is a equal to in this case? It's 2, right? A is equal to 2. Because remember, the y-intercept is that a value if it's an exponential function. Over here, what's a equal to here? A is equal to 5. So a lot of things the graph is giving me right off the top. So out of all the options I have, this one right here, I can use that very first one. Y is equal to, I made a mistake, right? Thanks for stopping me, guys. This one is decreasing, so 0, b is between 0 and 1. My bad. Okay, this is 0 and 1. It's Monday. You got to give me a break here, guys. Here, it's increasing, so b is greater than 1. So my bad. B here has to be greater than 1. So this one right here has to be the equation 5, 2 to the x. It makes sense. A is 5. I knew it anyways. B is greater than 1. Perfect. So this one must be y is equal to 2, 0.1 to the exponent x, right? Because I know it's decreasing and a is 2, so that all jives. So let's look at this, the two logs here. Here, I know it's decreasing. And that tells me that let's get this one right, okay? It's decreasing, so b is what? B is negative. I know that. I really can't find the point 1, 10, I guess it's here, but I'm just gonna go with what I have, and it has to be this one. Negative 2 natural log x. It's the only one that has a negative b value, so this one is decreasing. So this one has to be 6 log x, and b is positive, so I do expect this to increase as it shows. So that's how you mix and match. I don't think this was too challenging. I didn't really, put it in a scenario where you really have to dig down deeper, where they kind of look the same, but they may have different y-intercepts. So be prepared for something like that, though, moving forward. And our first word problem. So I don't know if you did this. I would really focus on word problems a lot. Devote your attention to word problems whenever you have that scenario. So the equation that models the time required to reach a particular radiation level. Was this on the video? Oh yeah, so you did this. Okay. You realize that time is your y variable, right? Okay, so I'm gonna skip this one then, if you've already done that. Maybe all I'm gonna do here is just show you the fact that this is my y variable, which is time. So time goes on the y-axis, okay? And x is the radiation, the intensity of the radiation. And I have to tell you this throws some students off because they're like, well, where do I start here, right? The important piece here is to find your x-intercept. Find that x-intercept. It's a decreasing function, okay, which is 1,522. And then you try to find points that get you closer to the y-axis. Okay, so 266 was a point on there, so I used that one. And then I found one more somewhere halfway between the 2 points that are kind of fixed. You find another one to help you determine that curve and when does it shoot up like that, okay? So x-intercepts are very important here, so keep that in mind. So let's skip this and go to, did I do 39 as well? I didn't do 39. So that's where we're going to go next. And then I'm going to give you some class time to work on some more. Okay, it's important for you to do that. So let's enter that into our calculator. Before we even read the question, I'm just going to ask you to type that in. It's natural log. Natural log. And so for now, I'm just going to leave it there and read this. The diameter of a tree grows according to the following equation, where d is the diameter of the tree in centimeters and t is the time in years. So t is on the right side, correct? So in this case, it's time and a y variable is your diameter. So in this case, we don't have the weird scenario where your y-axis is time, okay? This is kind of what we're used to. It says make a graph of the diameter as a function of time. So let's figure that out on our calculator, see if we can make this appear on our calculator. Maybe before we start, I will say that 5.13 is something that I could possibly use to make my graph. B is positive, it's greater than 0, so increasing. And it's a word problem, right? So we're going to just stick to the first quadrant here. This is time, and this is the diameter. So because it's increasing, it's going to go like this. It's going to start somewhere on the x-axis and go this way. time is x because t is on the right side of the equation, and that's always x. Okay? If this had been t, then we would know that time is our y variable. Yeah. So we're expecting something like this, guys. So we were not considering the other quadrant here. So let's make our graph here. I'm going to try that with a ruler. This is going to be time, and that's going to be in years. And this is the diameter in centimeters. And if you want full marks, I would suggest you put the equation somewhere on your graph. I'm going to go and just add that right here. Okay. Start with x-intercept. Okay, you should start with your x-intercept. So let's make that appear on our calculator screen. I'm going to go ahead and hit graph. Oh, there it is. It actually works pretty good for what I had. Let's all look at the same screen. I think that would be nice. So I'm going to go zoom standard for now. Zoom standard is at 10 by 10, right? I'm going to try zoom fit. Why not? Zoom fit is the option 0, right? It's a little bit better. That's what I see. Let's find the x-intercept. y2 is equal to 0. Second, trace, intersect. So y2 is equal to 0. Graph, we're going to find that intersection there. That's my x-intercept. Enter, enter, enter. What's happening here? Enter, enter, enter. So it's 0, 27, 0. Another point is 1, 5.13. This one I just read off of the equation. And I'm going to read a little bit further down. It says that determine the diameter of the tree after 15 years. So why don't we use that as well? Second, trace value. Let's figure out what the diameter is when x is equal to 15. I most likely will have to increase my window a little bit. I'm going to check my window. My x max, I'm going to go to 20. Because if I want a time of 15 years, then I need to make sure I show more there. And look at that, I increased it, but I don't see much up here. So I also have to increase my y max. I'm going to, I don't know, 30. Y max 30. Hit graph. That's pretty good. Second, trace value, x is equal to 15. Y is equal to 15.797. So it's 15.8 rounded. So it's 15.80. I'm going to highlight these points. So I found point number 1. I found another one that I could have just read off of the equation. And I have another one there. I would say have 3 points to help you out. So along the x-axis, I'm going to go all the way to at least 15, if not more, so maybe 20. So let's see here. 5, 10. I can spread it out more. Hold on. I can do better than that. I have space. So I can go 5, 10, 15, 20. Okay, so 5, 10, 15, 20. I know my key is probably different, so don't, if it has all the points that are supposed to be on there, if it looks like the function, then you're fine. I need to go all the way to 1580 here. So I have to be a bit smaller here. So 5, 10, 15, 20. I'm going to do the same increments, but you can tell that the gaps are smaller, and that is okay. X-axis and the y-axis can have different scales. So let's plot them. 0.270 is like right here. Just make sure it doesn't touch the y-axis. 513 is right about here. And then 15 meets with 15.80. Right about there. I go through that point and then I curve. It doesn't tell me that this stops, so I go arrowhead on that one. Question, does this make sense? The graph, would it make sense when you see this? Like the diameter of the tree, it gets wider and wider and wider, but does it keep going wider like by a lot over a certain period of time? No, right? A tree kind of like reaches that maximum width or the diameter, and it kind of just stays that way. It may increase by a little bit, but not a whole lot. So it kind of grows really rapidly at first, but then it kind of plateaus, right? It kind of just flattens. It will still increase by a little bit, but not by a whole lot, okay? So keep that in mind. All right, B. Determine the diameter of the tree after 15 years. I already did this, so I'm just going to I'm still going to show my work here. X is equal to 15 because that's time. Because remember, guys, they're asking if time is 15, what is the diameter, right? So in a sense, they're asking you for that point on the graph. And so Y is 15.80 years. Is it okay to state years with decimals? Yes, because you can bring years, you can bring it down to days, to hours. So time and years, absolutely decimals are fine. C, determine the amount of time required for the diameter to reach 20 centimeters. So they're asking what time, right, how much time is going to go by to get to 20 centimeters in terms of the diameter. So we need to let y2 equal to 20. Then we go second trace, intersect. And I would have to say this again. Always make sure you adjust your window accordingly. It may not work out for you if you don't first change your window parameters so that you can actually see this. So I'm going to try it. See what happens. Y2 is equal to 20. Hit graph. And it's not meeting, right? Based on my window, it's not meeting. I think the easiest one is to just chase the curve. We're going to increase our X max to, I don't know, I'm going to go 100. It might be overkill, but it's still all right. You see everything. So let's find that intersection. Second trace, intersect, enter, 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 and there we go. X is equal to 43.56 rounded, right? 56 years. You got it. Explain the meaning of the x-intercept. The x-intercept is 0.270. What does that mean? Try to think of it this way. This is time, and this is the diameter of the tree. So a little bit of time goes by, and it's at 0, like what's happening, okay? It represents the time in years that elapsed before the tree was even visible. Because if it's underground, I mean, some time is going to go by before you start actually being able to measure this thing, okay? From the time the seed was planted to the first sign of it coming up above ground, appearing above ground, took 0.27 years. About a third of a year. That's like what, 4 months? Just under. And this question doesn't ask you for it, but I would love for you to state the domain and range here. What's my domain here? Look at the graph. I always like the graph for you to. Time starts where technically? It starts right here. So for this particular instance, it's 0.27 until infinity. Technically, this tree keeps on growing indefinitely. And range, you have a diameter as low as 0 and as high as infinity. Okay? It just never, according to this, it never stops. That's the diameter of the tree. Yeah. The units for B? Let me check. Could it be that I'm wrong? Centimeters. My bad. Thank you. I appreciate that a lot, actually, because you know YouTube, the YouTube world is ruthless. They'll go thumbs down just because of this. Thank you. Centimeters. Can I have 0.8 of a centimeter? Yeah, that's fine. You can keep the number as is. Do you want one more? One more? Or do you want to fly solo? One more? Okay, let's do one more. If you want to tune me out and just work on this by yourself, you go for it, right? You go for it. As long as you're working on this, I'm fine. So let's type this into our calculators, and then we'll read it. Basically, I want you to, whenever you get an equation on the exam, type it into your calculator. Just do it. Don't even think about it. So it's negative 259.65 plus 63.38. Log, it's log, right, x. Oops. And get your variables right. Like figure out what goes where. Okay, can you do this in your notes? This is your x variable, and this is your y variable every time. Okay, there's no arguing with the question. Okay, this is x, that is y. So that means that what does A tell us here? What does it represent? A is the target value in dollars to be reached. So I'll just say it's the target value in dollars. And y, right, t, which is the y variable, is the number of years. So it's years. Okay, so every single point is going to be dollar years. Okay. I should first read the question, right? The amount of time required for an investment to grow to a stated amount is given by the equation below, where t is the number of years required and A is the target value in dollars that you want to accomplish. You want to reach that goal. The initial amount of money in the investment is $12,500. What is up with that? What's the initial amount? What would time be at the very beginning? 0. So basically what this question is giving me is like, if time is 0, no, wait. Time is my y variable, so you got to be careful. I will have $12,500 when time is 0. So at the very beginning, I'm investing $12,500. Okay? That's when it starts growing. So in a sense, if you want to just have a sketch here, okay, knowing that this is time and this is money, okay, you'll have 12,500. Like somewhere here, you'll have the 12,500, and then this thing will keep growing. Okay, it's going to go like that. So let's graph this thing on our calculator. Let's see if we can make this appear on there. So I typed that in already. I'm going to hit graph, not expecting a whole lot. It's not working for me. I'm going to try zoom standard. I'm going to first reset my window. That's why I use zoom standard first. Okay, you have you're looking at the origin here, and then I'm going to try zoom fit. So zoom fit, press 0 at this point. And at least I start seeing the curve right there. Okay. So let's look at what my window is telling me. Okay. I'm at x negative 10. I don't need to see that much, so I'm just going to go negative 2 there. X max is 10. How does that work? I know that my x variable, right? I know that the initial amount is 12,500, so my x-axis should be seeing way more than just 10. I'm actually going to go type in $50,000 or something like that, way beyond the 12,500 that I start with. So let's try that first. X max 50,000. Hit graph. What happened there? Let me try 13,000. Let's see if that works for me. Still don't see anything. What could this be? And I see the problem right here. So that's why you have to be careful with zoom fit. I see the problem right here. Y min and Y max, they're both negative values. Like, what's up with that? I don't care about the negatives. So I'm going to go -5 for my Y min. And I'm going Y max. I want to see above the X axis. So I don't know, what should I go with? Let's go with 200. I'm going to try it. So I'm going to leave that calculator there, the window. That's what I'm doing here. Trying to make this work because something wasn't working for me. Hit graph. Oh, I saw a little tail here, right here. I need to see way more this way because remember, 12,500 is where you start with the money and then it keeps growing. So I'm going to go window, X max. I'm now going to type in the 50,000 that I had earlier. X max is 50,000. Hit graph. And now I start seeing more. Okay, so this is where I have my initial amount of money. And remember, this is money. The x-axis is money, so that's growing, right? You want it to go further to the right as far as possible because that means more money for you, right? So that's right now where I'm at. Let's find that x-intercept. Is it 12,500 exactly? I think I tried to make that work. But let's say I hadn't mentioned this tidbit right here. You would have had to find the x-intercept. Let's make y2 equal to 0. There it is. Let's find the intersection. Enter, enter, enter. It is 12,494 and 48 cents. What's up with that? I'm going to find that here. So the x-intercept, I'm going to write this down. Y2 is equal to 0. Second trace intersect. So that's 12,494 and 48 cents. And don't worry about this too much, the discrepancy. Don't worry about that too much. On an exam or on a test, we wouldn't do that to you. Okay, so don't worry about this too much. This was probably just to help you out to figure out a window that works. That's probably what this was all about. Okay? Make a graph of the time required as a function of the amount of money for the amounts 10,000 to 100,000. So let's go ahead and do that. Let's make our sketch here. Our graph, I should say. This is amount of money, amount invested, and that's in dollars. This would be the time in years. So remember, time is your y-axis here. Okay. And I'm going to use my ruler to help me out here. I'm going to go 10,000, 20,000, 30, 40, 50,000. So this is my $50,000 mark. 60, 70, 80, 90, 100,000. So I'm just going to make sure that the numbers line up with that, the marking there. So I'm going to have up to 100,000 along the x-axis. And before I go figure out my y-axis, okay? Before I do that, I want to talk about this one right here. Look at this value where my pencil is hovering right now. What do we know about a point on this graph? It would be 1, negative 259, right? Does that help me in this particular case? It does not help me. Like 1, negative 259 would be in the negatives here somewhere, so I'm omitting that. Okay, I'm not including that. What I'm going to start with instead is this one, 12,494. This is 10,000. This is 15,000. So 12,000 is somewhere in there. Okay, so that's where my graph is going to take off from. And it's going to do this. But help yourself with some other points. So let's figure out, let's say we want $100,000. How much time is that going to take us? just for a reference so we know where to aim for. Okay, guys, I'm doing this so we know where to aim for. Okay, so 100,000, let's figure that out. I'm going to figure out when the money is 100,000. I'm going to figure out how much time that's going to take me. Second, trace x is equal to 100,000. And let's figure out the y value. Second, trace 100,000. Is it going to work for me? Let's see. Error, doesn't like it. And I know why. I know that my window only goes to 50,000. So let's change it to like 120,000, my X max. Sometimes it looks pretty good, the screen there. Oh, I don't know. I don't get this camera. So X max, I'm changing it to 120,000. And now I'm going to find that $100,000 investment. It takes me 57.25 years. Okay, so I have another point now that I can use to give me a reference. Because remember, we want to know, we want to have the right shape of this graph. Okay. So 100,000, this should be 57. So watch what I'm going to do here. I'm going to go 10, 20, 30, 40, 50, and this is 60 up here. So 20, 40, 60. Good enough. Go ahead. So 100,000 meets 57. This is 50. 57 is right about there. Close enough is good enough. So this is that third point, the second point, I guess, that I found. Let's find one more, somewhere in between. So you either pick 50,000 or 60,000, one of them. I'm going to go with 60,000. So repeat the steps. Second, trace value. X is equal to 60,000. And you are at 43.19. So again, x-intercept. This is my second point and another point. So 3 points to graph this properly. So 60,000 gets me to 43. Right about there. And now I have everything I need. To keep going. Somewhere on this graph, I'm going to include my equation. Log of A, sorry. And there's my graph. Okay, let's answer those questions there. Determine how long it would take to reach 25,000 and 50,000. Let's do them both at the same time, because it's very doable. So for B, how much time if you have 25,000, sorry, they want to know that. C, how much time for an investment to grow to 50,000, okay? So we go second, trace value, x is equal to 25,000. Second, trace value, x is equal to 50,000. And I'll just 25,000 is 19.09 years it would take to get that much money for your investment to grow to 25,000. Second, trace value, 50,000 is 38.8 0.17 years. D, determine how much money you could have in 25 years. They're asking how much money in 25 years. So Y2 is 25. We go second, trace, intersect. Let's see if that shows up on our screen. Yeah, it does. That's my 25 line. Second trace 5, enter, enter, enter. And it is X is equal to 30,985.92 cents. As long as you have a unit there, you're good to go. We're going to leave it there. So for tomorrow, okay, I want you to try all the way to page 42. I believe it keeps going a little bit. Yes, I'm going to, because I did a bunch, I'm going to say all the way to 44. Page 41 to 44. I'm mixing it up with exponential. There's an exponential question as well. Okay, let me give you a heads up here. At the bottom of this page, if B is negative, okay, and you have a word problem, you will expect something like this. The graph will go this way, and at some point it's going to hit the x-axis. Okay, must have. You must have your x-intercept. Okay, no matter which scenario you have, but it's a must-have. Will this thing ever touch the y-axis, guys? It will not. So you have to have an arrowhead here, and it decreases to the point that you reach your x-axis. So that's going to be the next question, actually, on 41. Has this scenario that you need to be aware of, okay? So it's a little weird because we're used to starting at the x-intercept and going. This one kind of comes from the y-axis and hits the x-axis there, okay? Thank you, guys.